Keybase is an open source key directory that allows users to send and receive encrypted messages and verify identities. Max Krohn is the co-founder of Keybase and also co-founded OKCupid. Max, welcome to Software Engineering Daily.
Thank you, Jeff. Glad to be here.
Before we get into Keybase itself, let's provide the listeners who have varying degrees of engineering expertise with some basic context about encryption. How do you explain encryption to a lay person like my grandmother?
Well, I agree. It's often a challenge. I think there are some cases where people use encryption every day. The most obvious one is when you click on your bank's website and you see the little green lock in the upper left-hand corner. That's encryption, and not only is that encryption, that's a good example of public key encryption. And so, you could tell your grandmother that when you're talking to Chase, when you're trying to look at your balance or something, it's a good idea for people elsewhere in the internet cafe you might be checking your balance from to not be able to see that what you're doing. And so, encryption is the way to prevent others in between you and the person you're talking to from intercepting the message and reading it. So that's like one of the easiest explanations I might provide.
And so how do you explain public key encryption to a technically minded person, like somebody who's not a programmer but is very familiar with computers, maybe a millennial type of person?
That's another great question. And when we think about the future of Keybase, we're really hoping at first to go after people who fit exactly that description, who may or may not be computer programmers, but at least know which questions to ask. And the idea of what is public key encryption might be one such question you can ask. And the typical explanation is just the bank scenario can work just as well to explain it. And the idea when you sit down at your browser and you try to connect to Chase, obviously, you and Chase didn't get together in a back room to exchange credentials. You did not, exchange a little piece of paper with a bunch of secret codes on it. So what that means instead is that you, as a user, ask Chase, what's your public identity? What have you published to the world about how to get in touch with you? And your browser and their server were able to handshake just on the basis of that. And so, in that sense, it's like a classic use of public cryptography, and it's a very scalable system. So you can have one server like Chase.com server, and it can speak to billions of people securely without having to make a billion offline key exchanges before the connection ever happened. So that's the most basic idea behind public key encryption. And if I were to go maybe one level deeper, I would describe in public key, there's a private key that you keep to yourself and a corresponding public key that you expose to the world. And if you've done so correctly, that means that anyone can look up your public key and make encrypted messages for it. And only the people who own the corresponding private key, meaning only you, would be able to receive those messages. And so that's maybe one level deeper. If I wanted to talk to a friend who is particularly very interested in this stuff, I would say, and by the way, public key crypto is not just encryption. There's a complementary feature, which is integrity protection and proof of authorship, which is just as interesting as encryption, which is often using the same techniques and the same kind of underlying infrastructure.
What is Keybase?
So Keybase, as it stands now, is a project that I started with a good friend of mine, Chris Coyne, and we were both co-founders at OKCupid. We left the company in 2013, and then we started working on a bunch of various projects, some of which were kind of frivolous, some of which were a little bit more serious. And Keybase was one of the several projects that we worked on during that time. And we thought of it at first as a way to make existing public key technology that some small set of advanced computer users were already using to make that system easier to use. And the technology I'm talking about here is PGP. So that's something that stands for pretty good privacy. It's been around since 1991 or so, and what it allows folks to do who really care and know a lot about what they're doing, it allows them to send emails that are encrypted and signed in such a way where even if you and I are both sending emails between Yahoo and Gmail or any sort of hosted email provider, we still get some guarantees that Yahoo and Gmail can't read the emails we send, and they can't tamper with the payloads of our messages. And so that is PGP. It's been around forever. It is not in widespread use. And so we started thinking about how can we make this software, which has a bunch of warts, but it's kind of held up pretty well over time. But how can we make it more useful to people? And our first hypothesis was that what made PGP so hard to use is that it's very difficult to, in your mind, think of a person like Jeff Meyerson and actually figure out what your public key is to bootstrap this whole process. And so if I wanted to send you a PGP encrypted email, the first step I need to do is I need to find your public key. And the way PGP is set up now, it's not a well-solved problem. And by contrast, it's actually a pretty poorly solved problem, and that is the more famous you are, the more people who are impersonating you and publishing keys claiming to be you, which makes it very hard to know if you've got the right one. And that is a fundamental problem with this technology, that it all depends upon the sender getting the correct public key of the receiver. And the infrastructure for doing that is, in the case of PGP, it wasn't great. So we sat down and said, what if we could solve this one problem of PGP? What if we could make it a lot easier or more convenient or reliable to look up people's public keys? And that's where the idea of Keybase came. And we had this pretty simple notion, which, though we hadn't read the papers, other people had previously suggested it. But just if you have this one public key, it just makes sense that you should broadcast it from as many publicly visible places as possible. And so if you are known by your podcast or your web page or your Twitter account, you should basically, on all those 3 or 4 places, say, by the way, this is my public key. And that way, if I want to look you up, I kind of check all 3 of those places and I say, is this the same guy? Is this the same key? Yes. All right. Now I have a lot better guarantees that it's Jeff and not someone pretending to be Jeff. And we noticed that people on Twitter did this even before we started Keybase, but it was very ad hoc and everyone had a different way of doing it. And it wasn't digestible by computer programs. And so we said, why don't we make this concept a little bit more formal and make it easy for a computer program running on my machine to figure out, who's Jeff, who is he advertised, where is he advertised his public key, and let me go check those places and make sure that all the crypto works out. And once I've done so, once my client has done so for me, now I have a pretty good assurance that I didn't used to have. I could say, wow, either someone who knows Jeff well took over all his different accounts and published a fake key, or this is actually Jeff himself who was doing it, publishing Jeff's actual key. And we think that guarantee is pretty good as far as you can go with PGP technology. So we launched a system to get that done. And it got pretty good. I think it got a pretty good reception. And while we were at it, we tried to simplify a bunch of different parts of PGP to make it more accessible for users, to not have as many fussy decisions users have to make. And so we kind of iterated on the idea a little bit, and we wound up with the Keybase site that we currently have now. So that's the very beginning of what Keybase is or was, but it's kind of a different question. What's Keybase going to become?
So we'll get into that eventually. The Keybase website says, quote, the goal of Keybase is to let any security software be powered by usernames instead of offline key exchanges, end quote. Could you explain this in more detail?
Sure. So if you wanted to use PGP the way the authors intended, probably what you had to do is you have to go and meet the people you eventually want to communicate with offline and exchange credentials. So you might have heard of something called a PGP key party. Maybe you haven't, but it's a party in which a bunch of usually men get together and look at each other's driver's licenses and look at each other's PGP keys and exchange those credentials between each other. And once they've said everything is good, it looks like it matches up, they go back to their computers and they sign statements saying that, I met Jeff, and I saw his driver's license, I saw his PGP public key, I'm signing that as Max, and now the whole world should see the fact that I've made that statement. And, it's it's an interesting hack. And the idea was that if enough people did these exchanges in small groups, eventually the whole world will be connected through maybe like 4 or 5 hops, but at the same time they'd still be connected. And now, even if you and I hadn't met in person, if we hadn't exchanged credentials this way in person, we still could try to find mutual friends who we trusted, who eventually would trust each other. And that's this idea of a web of trust. And that's the way you used to exchange PGP credentials, and a lot of times people still do it on their business cards. But it's an inherently kind of offline model, and it involves exchanging key fingerprints, which is a little bit ugly. I mean, you have to look at these long hex strings, which is a little bit error prone if you have to do that manually. And what we hope to do in Keybase is that to get you back to what you probably are more comfortable in thinking about. So you might be more comfortable about usernames on services that you either follow or you've starred on GitHub or you have communicated with on Reddit. Those names already make sense to people. And our idea was bootstrapping identity based upon those credentials and not the credential of having met someone in person. There's actually one more thing that we thought was interesting about the way we chose to do it, and that is the notion of identity might be changing. And in the 90s, when PGP was invented, the driver's license-based identity idea made a lot of sense because you probably only want to communicate with people who you had some sort of physical idea of who they were in the real world. But actually, in 2015, that notion is irrelevant in a lot of cases. What matters more is that you're talking to a Twitter personality who you know by their blue check mark, or maybe a famous software developer who's made a lot of code that you're dependent upon, and the credential that matters there is this is the guy who actually wrote the code. And so therefore, this idea of a person is really the combination of their social identities is actually a more powerful and general idea than this idea is of that we hope to replace. The old idea of a person is just who their driver's license says they are.
When people talk about why Facebook was so successful, many times they will say Facebook was successful because it cracked the identity problem. How does Facebook's notion of identity compare to the future, or I guess even the present notion of how Keybase thinks about identity?
That's a really good question. So I think that the biggest difference is that in Facebook's case, users really need to take Facebook's word on it. And for instance, let's say you published somewhere on Facebook, "This is my PGP fingerprint," which actually they allow people to do now. So the question is Facebook always going to are they always going to actually present to other users the same fingerprint that you put on your Facebook page, or are they going to lie about it? And so it could be someone can break into Facebook and deface their website and exchange keys for keys they wanted Facebook to show. It could be some government would force or compel Facebook to actually publish the wrong identity there. And so in that sense, whatever Facebook provides, it's obviously better than nothing, but you're really trusting Facebook to do to do the right thing and to do it consistently. So in Keybase's case, we made a lot of provisions to prevent our website from being hacked or our website from being compelled to show malicious data. And I think if you're going to be in the security business, you have to take a lot more precautions. And I think that's the difference between Facebook's kind of way of thinking about identity and ours.
So when I sign up for Facebook, I just enter my email address, I enter my password. Maybe there's some other steps, two-factor authentication to validating who I am, and then from there on out, I can use Facebook's login with Facebook utility to verify my identity on all kinds of other platforms. If you compare that with Keybase's onboarding process, Keybase has a bit more of an intense onboarding process for people who may not be technically aware.
Right.
There's some places where you have to enter a public key or generate a public key,
right?
Public-private key pair.
Mm-hmm.
So I'm sure you think about this trade-off between the upfront work that a user has to do versus the amount of transparency and security that the user knows about the process. I mean, Facebook seems like more of a black box type login process, whereas Keybase is more you truly know what is going on mathematically. So how do you think about those trade-offs?
Well, I think the answer is that we realize what we have now is not the right place in the spectrum. We
You mean in terms of Facebook?
No, in terms of, well, I'm just saying whatever we have right now is way too complicated, and we know
what Keybase has right now.
Yes, we share with you the concern that this is not ready for mass adoption. We are 100% convinced you're right.
Well, just to clarify, I didn't mean this as a criticism. I meant it just as this is like a proof that we are doing this in a way that's transparent and has integrity.
It's true. I mean, I think transparency is incredibly important to us in our product, which is why, sadly, we can't even rely on web technology going forward. And that makes us very sad because it just means we have a lot more work to do on our side. But, I mean, this point has been made by many that the whole process of going to a website and downloading JavaScript from the server and executing the JavaScript means it's very hard to get any guarantees that the web server is behaving properly. And so that's very bad for transparency. And though we try everything we could do on the Keybase website to avoid cases in which our website can be hacked, we fully understand that we haven't solved the problem outright. And so just like a million different ways I can go with answering this, but the first thing I want to say is, in terms of transparency, we're moving towards a Keybase in which the clients are going to be running on your machine, and open source clients where you could download the software, audit the software, and check out exactly what we're doing. And we think that's crucial towards getting a real security product that has a better defense against our website or our servers being hacked, which is super important for us. The other thing I want to say is that we fully realize that our first kind of prototype of Keybase has a lot of shortcomings, and I could list all of them, but suffice it to say, usability is the biggest one. And so our next version of Keybase is going to be significantly simplified. We don't want to talk about keys. We don't want to talk about private keys or public keys. That's not what people understand. We want to change the whole terminology and the whole set of decisions users are making, and we're pretty far along in this. But to give you an example, users really understand the idea of I have a phone, I have a laptop, I have an iWatch or an Apple Watch. These are concepts that are very easy for them to understand. As soon as you mention secret key, public key, they get confused, and so why should we even bring that up? It should just be like, I have Keybase installed on my laptop, and I want to add my phone, and that's the level that we want to talk to people and kind of guide them through the process. And so we are like 100% focused on this, and we think this is really where everyone who's tried this has gone wrong in the past. It's kind of like a last mile UI issue that like the technology, the protocols, the algorithms are all like so understood at this point, but what isn't well done is like the user experience and kind of people's interaction with the product. And so that's where we're dedicating almost all of our focus. And I could kind of hear in my mind some real hardcore security fanatics saying like, oh, if you do all that, there'll be these attacks, and that's not the right way to look at it, because in the hardcore security fanatics way of looking at the world, there'd only be 0.01% of people who could possibly use crypto software, and everyone else would be screwed. And we think that a way better outcome would be for more people to have access to the software with potentially a couple of trade-offs that the hardcore fanatics are unhappy with, but we're fine with, and just to get adoption, several orders of magnitude bigger than it is now. We think that's the best thing we could do for securing people. If you want security communication software where no one you ever want to talk to actually uses a software, then it's useless. It's not really buying you much. And so the number one goal for us is to try to get as many people as possible to use the software, subject to the constraint, of course, that it's secure and that it's has good defenses against the attacks that we think are most likely to try to hit it.
So let's get into some use cases to motivate the previous discussion we've had about Keybase. How would I use Keybase to encrypt a message that I wanted to send?
So are you referring to our current incarnation or the product that we're building now?
I guess both. And if you could outline how it currently happens, and then the ideal case,
Sure.
how you want it to happen eventually.
Sure. So the current way of doing it is, I mean, you have several clients open at your we have several clients open to you right now. The first is the website client, and so were you to use the website, your experience would be you find someone you're interested in communicating with, you click on their profile, you dump some text into a text area, you hit encrypt, and then it outputs a PGP encrypted message, which then we ask you to send to your friend however you want to do it. So that's the most convenient yet not exactly secure way of doing it. If you cared a little bit more about security, what you ought to do instead is to install our software, which, by the way, currently only runs as a command line utility. But you'd install that command line utility, and you type Keybase encrypt, and let's just say you want to encrypt for me. You type Keybase encrypt max or max taco at Twitter or max taco at GitHub, or you could just reference me by any of my publicly proven identities, and then you'll basically have, at that point, the command line client will be asking for input. And so you can give it a file, you could type something, and then when you say end of file, it will then output a PGP encrypted blob, which again, you would be copying into your email client or writing to a file, and then you are then in the position where you need to send that big blob of PGP stuff to whoever it is who you want to receive it. So all we're doing is the encryption, and we ask the users to actually move the data themselves. We did that because it's kind of the PGP way of doing it, and that's just like the simplest thing that we can come up with. Going forward, though, we realize oftentimes that people don't want to just encrypt stuff and have that stuff sit there. Oftentimes they want the stuff to be delivered to the person they're actually sending it to. And so our new way of looking at it is we want to just go directly into those applications that people are most likely to use encryption for. And the two most obvious ones we can think of are just exchanging files and exchanging little messages. And so the thing we're building first is a file system. And so what we want to make possible is that you could drop a file into this little folder on your Finder, or if you use the command line, you can copy a file into a path, and depending on what that folder is called, it will encrypt it for the right person, it will upload it to our servers that we're renting on AWS, and then when that person wants to go fetch the data, they just do the opposite, download it, move it from AWS, and their software is doing all this behind the scenes. They don't have to think about it. But the software would do the opposite. It would pull the data down from AWS, and then it would decrypt it locally, and then show it to you as if it was just a regular file. And so we want to basically streamline this whole process. And what it currently takes 10 commands on either side, we want to just take one command and just hit the use case that we think people are most likely to want to use Keybase for. So that's the thing we're building right now. We're building a file system where anyone can move files into these folders, and the folders are named by your Keybase account, or as in the previous example, they're named by your Twitter account or your GitHub account. And so, for instance, I could do copy Keybase / private / max taco at Twitter, and that's actually putting a file into the folder that only I have access to. I could do the same for a folder I want to share with someone else. So I could do Keybase / private / max, Chris, and that's just a folder that Chris and I both have encrypted access to, and no one else can see. And the data is all stored and hosted on our servers. And so that's what it looks like from a command line user, and obviously from a GUI user, they get a little bit more of a user-friendly experience where they don't have to type in command line, type in path names. But the important part about the software is that it's doing the steps that were ordinarily lots of different things, just as one convenient action for end users. So that's our goal for the future.
How is Keybase useful for sending Bitcoin?
Here's one way I would do it. If I knew your Twitter account, so let's just say it's Jeff at Twitter. I actually don't know your. It's actually No, I'm not going to say what it is because I could be wrong. But let's just say for now it's Jeff at Twitter.
the_Prion.
Okay.
For any listeners that are interested.
Okay, the_Prion. So I would do two things. First, I would make a random Bitcoin kind of address pair using my own software. So with Bitcoin, you could basically have as many of these address, wallet keys as you want, right? So I just make a new one, make it out of thin air, and I transfer the money to the public side of it. And now I just need to get you the private side of it, right? And so I take the private side and dump it into Keybase/private/max, let's just say Jeff at Twitter. And then once I've done that, you can now read the file out, and so you have access to the secret key, and so then you can take the Bitcoin and do whatever you wanted to with it. So that's the easiest way I could think of. I mean, roughly, all I need to do is share with you this short secret, and we could use KBFS to do that. And so, of course, you could write software to do that automatically. You could write all sorts of scripts to do that automatically. And the idea we have for the file system is that it's a really convenient API for people to write slightly more complicated software on top of it, where all the interesting crypto is just totally hidden from the application, and the end user just gets to read and write to specially named files, and they get these great end-to-end crypto guarantees.
So we've discussed two sort of current usages. What I think is really exciting is the notion that Keybase could be used to share medical data. Could you talk about the future usage availability of medical data through Keybase's platform?
When we brainstorm usages for the product, we're typically only thinking about consumer uses, and we get a lot of interest from enterprise. And so far, we've said, we're not interested at the current point in kind of going towards more enterprise applications. I think medical data is a great example of something that ought to be encrypted, and moreover, that there's a significant financial incentive to handle properly. And we see a lot of times that people claim to have their data encrypted, and it turns out that the keys aren't stored in a secure way, or there are other very trivial failures that prevent the notion of encryption from actually working. But I believe in medical records and medical data in particular, there's a significant incentive to get it right, because I feel like software companies are open to tremendous liability if they screw it up. And so I think that's an example where we hope to see eventually some really good adoption of real correct crypto. What would it look like? Well, I mean, I've used some of these products like the Microsoft Health Vault, which I found a little bit challenging to use, and I knew it the whole time. I was kind of trusting Microsoft to do all the heavy lifting, and I knew if anyone had compromised their servers, all the data would be public. So I'm trying to kind of put. That's the only experience I have with medical records. So I'm trying to kind of.
Is this a space where people want to control their own data?
I think absolutely. The question is, there are so many middlemen between them and their data. Will they ever have a chance to do so? And what makes me really afraid of dealing with anything in this area is that the integrations would be tremendously painful. You'd have to integrate with so many different people's software running on so many platforms, and probably some of the stuff is like running on Windows 95, and I'm glad that we don't have to think about that right away. The other thing about HIPAA is that I think the compliance is rather challenging, and a lot of people have spent a lot of time decoding HIPAA and mapping it to crypto, and it's nothing I'd ever claim that we can do the way they want us to do without spending a lot more time thinking about it. So I got to be a little bit dodgy with that answer. If it were me, I would be super psyched to have my data on Keybase, and if I want to share it with my doctor, just copy it into max, my doc, and then know that no one else can see the data if they're not either me or my doctor. That would be an awesome thing to do. The problem is my doctor's running some crazy like office management software that then needs to deal with the data, and maybe that's a bigger security hole than the way of getting it to my doctor in the first place. So it's a little bit hard, I think, at least from my limited understanding, to kind of to hypothesize, I think, about it.
So it sounds like ideally somebody else will build this application
Oh,
on
yeah.
top of Keybase.
Oh,
So
yeah.
that seems like a good opportunity to segue to the discussion of the command line interface,
Yeah.
which is, sort of promises, well, it looks like it promises to eventually be a kind of a full-fledged developer platform. I guess first you could tell me whether that's correct, and also, in any case, tell me about developing that command line interface, because I know, one of the problems with building an API is you always have to maintain back compatibility, and so you have to be very careful about how large you make that API. Sometimes you really have to focus on making it as thin as possible. So tell me about that development.
Yeah, that is a great point. Our current story for this, and it's open to change, and our current story is that the easiest way for applications to build on top of Keybase is just to read and write from the file system in the various folders that we present, where the names of the folders will convey who can read, who can write, who is signed, and who assigned the data. That is our story. So in that sense, we're totally dodging this very complicated question and just saying we give you whatever semantics the file system gives you right now. And that's like a pretty well defined API that a lot of programs need to understand anyway. So that's our current story for it. When we think about kind of the future and do we want to build anything more complicated, we've often talked about maybe supporting the Git server API too. So instead of talking to a remote Git server like GitHub, you could actually talk to a local service running on your machine that speaks the Git API. And that's kind of like another example of how we can expose an interface to programs and to other software that they might already understand. So we were thinking mainly along those lines. In terms of can you sit down and write a program that can interface with this local crypto service running on your machine? Hopefully the answer is yes, but we certainly don't want anyone to do that right away. There are a lot of interesting kind of UI considerations that we have to come up with, and I think that's the biggest problem. And when it comes down to it, the crypto stuff does have a strong UI element to it. And when I first share a file with someone who I know by their Keybase name, our current plan is to have UI elements that show you, well, what are their other identities that they've proven, and how long have those identities been proven for, and things for you to understand that this is actually the right person you're talking to. And this makes a lot of sense for people on desktop clients. For people on servers, it doesn't make anywhere as much sense, and so we have a slightly different story for that. But I have to say we haven't thought much about the API that we want to expose, and as you say, support indefinitely, more or less, beyond the file system. So that's our best answer right now.
Every user on Keybase has a public signature chain, and these chains are hashed as leaves in a Merkle tree. What is a Merkle tree?
This is a great question. So earlier I said that Keybase strived for transparency and for this property that even if our server is compromised by our worst enemy, that the people using the Keybase software would still be able to at least detect the fact that the server had been compromised. And so the question is, how do you do that when a very intelligent attacker can do a lot of very subtle things? And so if you imagine my identity is of the form, well, I first signed up with my laptop, and then I added my phone, and then I proved this identity on Twitter, and then I became friends with Jeff, and I kind of made a statement saying I agree with who Jeff is on the basis of what he's advertised on Keybase. So what all of those different things are is that those are statements that I'm signing with my private key, saying this is something that I've signed that anyone else in the world can verify. And that's the fundamental building block of where we go with the site security architecture. So for every user, there's this chain of signatures, as you mentioned, and therefore we want anyone else's client to be able to verify anyone else's chain. And so that way, your client can know that the server didn't insert fictitious elements into my chain because the server never had access to my private key. So that's like the first level of security. But there are other levels on top of that, and we have a whole site of these chains. Now, what if the server is malicious and decides to roll back the state of the chains? If it just decides to leave off the last 5 statements that I've made, and those might be very important statements. They could be statements of the form, "Oh, by the way, I lost my phone, so don't trust any future signatures by my phone." And so, if the server were compromised and chose to leave that off, that's actually a security vulnerability that we're really afraid of. And so, our answer there is that at any given time, we on the server side construct a tree which is just basically the combination of everyone's chains and boil that down to one hash statement. And so in other words, if I tell you the hash statement of all of Keybase, it's like a 32-byte string. From there you can derive cryptographically the state of everyone else's chains in the whole site. And we make the commitment that all of those states of the site are ordered monotonically increasingly, so that therefore, if ever there was an attempted rollback, the clients would have enough information at their disposal to figure out that the server actually tried to roll back the state of the server. And so the mechanism whereby you can take a whole group of users and kind of hash them down to one value is a Merkle tree. And so it's a basic tree where that the server needs to have the whole tree in memory, but if a client ever wants to verify, he only needs to know the path from the root down to the leaf that he cares about. And so it's a really cool cryptographic construction that a lot of different systems have used, and we use it to get this property. We take one more precaution, and every 6 hours we take the root of our Merkle tree and we put it into the Bitcoin blockchain, which means now the server can't do this one last attack, which is to show you one version of the site and to show someone else a different one. And without the Merkle tree, without the Bitcoin blockchain, the server would be compelled to maintain that fork indefinitely. And assuming he was able to do that, he could potentially get away with showing one version of the site to you and another version to your friend. But with the Bitcoin blockchain, there's now only one definitive version that the server can ever show, because if it shows a different version, it won't correspond to what's in the Bitcoin blockchain. So that's like the last element of the security story.
So this is so fascinating because it's like, it's the type of thing people talk about with Bitcoin where, we're not exactly sure why this is going to be so... Obviously, you look at Bitcoin as a software engineer and you say, oh, this makes some fundamental breakthroughs, and it also makes fundamental breakthroughs that we haven't anticipated yet. And then you look at Keybase and you're like, oh, well, this is obviously one of those types of new revolutionary benefits that we have now. And I'm curious, is there any other point of inspiration that you've had from Bitcoin, or are there any other overlaps or synergies between Bitcoin and Keybase?
That's a great question. We often attract a lot of the same enthusiasts, I think. I think a lot of people who use Keybase are also really into Bitcoin and cryptocurrencies. And so, at least from our nucleus of power users, we see a lot of overlap just in terms of interest. We made a pretty deliberate decision early on not to totally kind of hitch our wagon onto Bitcoin, because we wanted to see how it played out and where it's going to go and which of the many altcoins is going to be the future. And so in terms of developing software, it's a lot easier for us to iterate if we control what the server is doing. So that was another reason why we kind of built our system like more or less complementary to Bitcoin. But as you say, we love the fact that Bitcoin gives us this ability to publish one definitive answer in such a way that we can't lie about it. We think it's an awesome feature. Other things that have inspired us, I think really this is a great example of people using public key crypto to do things that before they couldn't do. And so that also is inspiration. It's a system that's captivated people's attention and imagination, and it's just based on a lot of the same building blocks that as the system we're building. So clearly that's very encouraging to us. And obviously we love Bitcoin and love to follow what's going on with the ecosystem and kind of the new stuff they're dreaming up. So that's like kind of as a personal aside, it's just awesome to see.
This is Security Week on Software Engineering Daily, and I'd like to talk some about the security behind OKCupid. This isn't tightly related with Keybase, but it's extremely topical because, as you know, Ashley Madison was hacked recently, and we're finding out all these horrendous disclosures about that website. So, what kinds of security precautions did you take within OKCupid that are unique to a dating site, I guess I should say?
That's a great... Wow. So, OKCupid was the target of consistent attacks, and attacks that we rebuffed, but we always knew that there were various schemes attempting to break into the site and either to spam users or to defraud users or to get our database. And that was just something we knew from the very beginning. I mean, I think probably the 10th person who signed up for OKCupid was a spammer. And it was just an understanding we had from day one that this is something that we had to worry about. I think, and you know, I haven't been in OKCupid for a long time. At this point, probably 3 years, and you know, I presume they're still making really good decisions. But the one thing we did that a lot of people didn't do is we came up with a different site architecture for how to even build our everything from our web server all the way down through the microservices that were running behind it to the database. And we tried as best as possible to separate privileges and to say, well, this one part of the site doesn't really need access to all the data that this other part of the site needs, and therefore we just won't allow that to happen. And I think that was kind of a very, more or less like a principled kind of least privilege separation approach to building software that a lot of other sites likely didn't do if they were using off-the-shelf software like Apache. So that's one set of decisions that we made. We spent a lot of time just dealing with our perimeter security, and when it comes down to it, that's where a lot of things go wrong. And so we were doing two-factor auth before there was a convenient way to do it. And at one point, we were all walking around with little pieces of paper in our wallet where it was just like a series of one-time passwords. That when we rolled out that system, that was probably 2006. It was a lot of software that people tended not to use very much, but made us tremendously more confident that we weren't open to the most basic type of attacks, which were people rooting our home machines and SSHing in behind us to the servers that we were all kind of pitching in to administrate. So I think we kind of had a pretty good awareness that there was danger lurking, and we knew that the people who want to screw us over were smart enough to do what the Ashley Madison hackers did, which is just to dump the database and kind of deal with it once the data was exported. And so we knew there was a threat, and we did everything we could to avoid it. And to my knowledge, we succeeded in that. But it's a really tough job. I mean, I don't know what the Ashley Madison folks were doing, and I don't know if they had their act together or not. But I know that if I were the one if it were my personal responsibility to make sure that something like a Dropbox or a box was secure behind the perimeter, I would not sleep very well at night. And I wouldn't, because I would know that the size of this problem is just like, there's so many ways into people's server infrastructure, and if there is a way to get the plain text out, I think with enough effort, someone's going to find a way to do it. And the bigger the system, the harder it is to get it right, because you have personnel coming in and out. You have, bad communication lines break down just at the level of, people running the system. And this is part of our philosophy as to why we think something like Keybase is necessary. I think a world in which everyone uploads their plain text to cloud servers is just not a world in which we're going to hold on to that plain text. And the only real principled solution is to only ever upload the ciphertext. Now, that doesn't work for OKCupid or something like it, because it's meant to be a matchmaker, and you can't do a good job of centralized matching, if you can't actually understand the data that people are uploading onto your server. So, I mean, I don't think a cryptographically enhanced OKCupid could ever work, but definitely for things like static documents, it's got to be the future that we're putting encrypted documents on the cloud and not the status quo of just hoping that a Google or Dropbox, a box will just keep these things secure indefinitely, because that's a tough thing to do.
The Ashley Madison thing was so dystopian because many of the engineers were actually spending a lot of their time working on these bot creation programs. These were bots that would talk to the male users. It just makes this like increasingly tragic. But do you think about this as an application for Keybase, like verify your humanity through Keybase? Because bots are an increasing problem, and it's kind of spooky.
God. I agree, and I don't want to tell you how much time at OKCupid we spent doing the opposite, which is fighting people who wrote the bots. And it was like, it was so frustrating because you show up to work and you say, I want to spend today like making this cool new feature, and instead you're like, why are all like the pictures on the profile on the front page showing me like email addresses of like some affiliate site for adult friend finder, and so we'd have these like cat and mouse games with these people writing bots to spam us, where it was really like a chess match where we were trying to do the simplest basic thing to catch them, and they would kind of counter, they'd parry, and we'd have to do something else. And so it's funny that OKCupid spent its time doing the exact opposite of what Ashley Madison was doing. Anyway, proving your humanity. So, oh man, I kind of feel like the better solution to those problems are just like active defense. And I know Facebook spends a lot of time dealing with it. And I know OKCupid does. And you don't really want a world in which to sign up for OKCupid, you have to spell out exactly who you are in a way that's not...
Take a blood sample.
Yeah, falsifiable. Yeah, because some people might want to be pseudonymous. And so I don't think I want a world in which you need to have a proven key-based identity to use OKCupid. I think it's a good example for something that you actually don't want. So,
but then so what? Like bot equality, or?
I think the right thing for something like OKCupid to do is just to fight off the bots. I mean, you could do it. There are all sorts of ways, and I think for instance, how much spam do you get on Gmail nowadays? I don't get very much, right? And I don't know if you use Gmail or not, but I think that there are good examples of bot hunting actually working. And it's never going to be perfect, but as long as the average user has a good experience and isn't too kind of put off by the bots, I think it's a problem you can work around. Now, the Ashley Madison problem seems like totally upside down, in that the incentives were totally broken, and the people were basically just dupes who were using the service. So that's kind of sad for a whole other reason.
Let's close off by talking a little bit about the software architecture behind Keybase. Why did you choose Go?
So this is a great question. During the Heartbleed thing, I think I kind of tweeted at one point, say what you will about JavaScript crypto, but at least you have bounds checking. And I think that's one thing you could say for Go, that you have bounds checking. And anyone who says you can only write good crypto in C is ignoring that problem. And so that's often how you get into trouble with writing software. You buffer overflows. So that's one thing in Go you get for free. Good things about Go, it runs on increasingly many platforms. The people who are interested in working on Keybase seem to all like Go, and here's the real good reason. The libraries for Go are just phenomenal, and I spent a lot of time in my previous life at OKCupid working in C++, and the problem with C++ is we saw it, at least back in the bad old days, is that it's hard to find libraries that are good and work well together. And so you could find a SAX parser, and you could find an HTML getter, and you could find an SSL wrapper, but good luck kind of making all those things kind of work together to fetch an XML page over HTTPS. And so that's the crazy thing we used to deal with it in C++ all the time. And you get that because there are so many different ways to do everything. There are different ways to manage strings. There are different ways to manage concurrency. And if every library makes a different decision, you just wind up libraries that don't really fit together very well. Now Go is the opposite. They basically sat down and you had a very smart and well-funded group of people making consistent core libraries that do almost everything you need. And that was just really, it's been an incredible boon to us. You could look at other ecosystems that have a similar rich set of libraries, maybe Python, maybe Node.js, but those are all interpreted languages, and so that's probably won't have that same, we wanted it to be compiled code, so for that reason Go was good, and also we like the libraries. Maybe in the Microsoft ecosystem, you can find like some good combination of compiled libraries with compiled code, great libraries with good documentation that all work together. But in the open source ecosystem, it's rare, and I think Go has done a tremendous job there. So I can complain about lots of things about Go that I'm not a big fan of, but everything has its warts, and we think relative to the other trade-offs, Go is pretty good. We're playing around with
garbage collection a feature or a bug?
I think a feature. I think a feature. If we were running some sort of server-side process that whenever it hiccuped, the users would see it because you're doing a MapReduce job and there were like 1,000 Go processes. If any one of them hit the garbage collector, the whole request would take a second. Like that kind of stuff happens, right? We don't have that issue. It's just all running on the client side, so hiccups are not magnified. They're totally containable. I've heard the new garbage collector is great in 1.5, so that's a good thing. And the other thing we're experimenting with, and I don't want to kind of commit us to this line of development, but we're having good luck reusing our Go code on iOS. And so basically we write the core of our library to run on OS X and Linux and eventually Windows, though we haven't ported it yet. And we could take this library and kind of monkey patch it or, really kind of integrate it with Objective-C in a way that's not the cleanest way, but it works. And so if we could reuse all the software that we've written for the command line in an iPhone app, like that would be such a relief to us because, this crypto software is hard to get right. You want to be very careful about all the corner cases, about, unchecked data, in processing user inputted data, and to do that in two different languages feels like twice as hard as doing it in one. And so we're very optimistic about using Go on both iOS and Android also. So we realize this is the cutting edge, and as I said, we haven't really committed our development effort along this path. But so one thing we've considered is that our core crypto library really exposes what looks like an RPC interface to the outside world. And so the outside world can be something like a command line client, it could be a GUI, it could be the file system that we're building. And it's just, we intend to have the service running locally on your machine that's doing all the crypto for you. So our current thought for iOS, and we have some early prototypes actually working, is that, what if a library just exposed an RPC interface to, the other half of the program? And so therefore, the only interface you'd really need to show is just some sort of read and some sort of write. And then internally, it's just a stream of bytes that goes between Objective-C and Go. And then all the kind of the function calls and the types can be reassembled on either side. And so it's an interesting way of doing it because obviously there are tons of, it's a big API, but when it comes to what we actually need to implement, it's just really read and write. And so that's our current thought about how to do it. And it seems like it's working, which if we get that working, I mean, that means we won't have to write all the crazy glue you might need to kind of put a Objective-C app together with a Go app, because a lot of times that's what happens. If you want to call a function, from Objective-C that's written in Go, you have to write a lot of kind of input and output kind of glue, which is ugly and adds up. And so this is our way that we can avoid it. So
is there a reason that wouldn't work in Android?
There's, as far as we could tell, there's no reason when the same idea wouldn't work on Android.
Wow.
And so I mean, it's just like literally we got this working today. So I don't want to make it seem like this is the way we're going, but like definitively. But we hope that if we did, this would just allow us to reuse a lot of code. And
Sure.
the other thing about this microservice, I mean, about this architecture of having the service is that, the service doesn't know anything about the GUI or like the user interface. It just knows about like, look up this user on Keybase and make sure all his proofs check. And so therefore we're still writing the UIs in the native languages, and we're just kind of doing all the crypto in Go. And so this would be great if we can do it. I've seen similar presentations from the folks at Facebook in which they kind of have a waste, like they have an interface that they use across all their clients written in C. And it's a little bit of the same idea, but we're just hoping to do it in Go instead of C.
Max Krohn, thanks so much for coming on to Software Engineering Daily. You've said some really interesting things, and it's been a pleasure having you.
It's great to talk to you, Jeff. Thanks so much for having me.